wearing this hat.
Looks good.
Okay. How many of you guys already know some Objective-C or some iOS programming? Okay. So what we're going to go over in this talk is we're going to go over the real basics of both the language in the context of some game programming, design patterns, and also some basic game programming stuff. We're going to do that by making a clone of Flappy Bird very, very quickly. But before we do that, perfect, get the screens right. Okay, cool. So, Make School is a college alternative for hackers. Basically, it started as two guys who went to YC with the idea of becoming like Zynga, but without having any engineers on staff, right? Like they were going to publish as many games as people could make, and they were going to help hackers and engineers with the design, distribution, getting users, all that kind of stuff. And they kind of stumbled upon the idea to teach people how to make games so that they had more games to publish. And then eventually they realized that there was a lot of other things that they could be teaching people as well. So here are some bullet points in that regard. I don't have my presentation notes on here. Here we go. Boom. Okay, cool. Okay, so they started about 3 years ago, and right now what they're doing is they have a 2-month summer academy that's in New York, San Francisco, and Palo Alto. Yes, somehow San Francisco and Palo Alto are equidistant from New York to the Bay Area, and worthy of having 2 separate locations so people don't have to commute between them. I actually spent the summer as an instructor for that summer academy, and I'm currently a director of engineering at a very well-funded healthcare tech startup. So I have a lot of real-world engineering experience as well as multiple hackathon winner and multiple company founder. Okay. So Make School is offering that program, and they just started offering a 2-year college alternative in San Francisco. They also offer a lot of free online courses, like the introductory course that we're going to go through right after this. And the curriculum is currently being used at MIT, Carnegie Mellon, and other universities. So Summer Academy is designed for people who have some object-oriented programming experience, hopefully from learning it in some context, but basically don't have any game development experience. And you come to the 2-month program, and in the beginning you learn about game design, and then you design your game, and then you start building it, and by the last week there's a demo day, and you have your app shipped to the App Store, and you start having users of your app. The other interesting thing is there's a lot of international students. It was a very international crew in the Palo Alto location. And you get to hear amazing people come and speak. At the Palo Alto location, I know that Sam Altman, who's the president of Y Combinator currently, and Alexis Ohanian, who is a co-founder of Reddit, came and basically, told their stories, and then had like a question and answer session about entrepreneurship, programming, whatever. So it's pretty amazing. Also, one of the founders' dads came, he came and he talked about a lot of interesting things. He worked very closely with Steve Jobs on the original Mac team, so he had a lot of amazing stories and experience to share. So there's big name brand people that you wouldn't know to hear exciting stories from, but have them. And that program cost about $6,000. Over 40% of the students there had some kind of a scholarship. Some were full ride scholarships, some were partial scholarships. there was a lot of interesting things like, I think Dave McClure, as an investor, was giving a couple seats scholarship, just fully sponsored for people to come to the program. And also, I'm not sure if there are any at this hackathon, but tomorrow night I'm going to be at MHacks, and I know we have some alumni there, so if you're interested, we can, connect you with someone who's been through the program, so you can chat with them about it. Last thing about Make School before we get on to the iOS tutorial. This is the new 2-year program, and it's very interesting because you can go through the program at absolutely no cost, and after the program, if it's been successful, if they help you get placed at an internship and they help you get placed at a job, then you actually pay tuition for the program after the fact. So what's really interesting is they're doing a gap year program where all these top universities definitely are comfortable with you taking a gap year to go and explore things outside of academia. A lot of them even encourage it, so you could basically try out this program at no cost or obligation unless you wind up getting a paid internship through the program, in which case then you would pay some tuition for it. And the program is really designed to help you get your foot in the door and real-world experience at like a top tech company in the Bay Area. The idea kind of is come to the Bay Area and give it a shot in a very supportive environment where you have resources to learn everything that you want to learn and connections to the companies that you want to go work at, instead of just like getting on a bus and moving to Silicon Valley and walking off the bus and not knowing anyone. So it's actually a really cool program. They help you with making sure you nail technical interviews, and it's not based on like tests and problem sets. It's really on helping you come up with your own projects in the same way that the summer program helps you make your own game and ship it to the App Store. They're helping you come up with sample projects. I know at my company we're hiring right now, and we're actually looking at a couple of the people who are currently in the gap year program, and one person of that group is a student of mine that I had the pleasure of working with this summer. And I was like, hey, he was pretty smart and he made a pretty cool game. And then I saw his resume since the summer program, and I was like, whoa, whoa, whoa. He made like a Tinder for food app where you can like go through and people can like decide what restaurant they want to order for their company from. And I was like, wow, that's a lot of progress since he just spent the summer making a game. So it's a really cool program. Happy to answer any questions about it afterwards. We're going to jump right into this where we're going to make Flappy Bird very quickly. After that, I am more than happy to spend about a half an hour answering any kind of programming questions, any kind of engineering questions, entrepreneurial questions, anything. I will make myself available. I think we have the room for that time. So, that being said, we're going to go to this, but before we go here, one last thing. You may want to like put this, write a note, bookmark it. There's an online academy that costs, I think, normally $100, but if you go to this link right now, you can sign up for it for free, and it'll teach you all the basics that you need to make an iOS game, and also I think it gives you access to an art library so that you don't have to be a graphical designer type person in order to ship a game to the App Store that's worth playing. So I'll let you guys write that down. It's make.se/friends. Cool. So that being said, we're going to go here to this link, and we are going to make us some Flappy Birds. I am going to reconfigure the monitor here so that I can see the same thing you guys can. Is that readable to you guys? Legible? Thumbs up? Okay, cool. Okay, so just to give you guys some idea, let's see if I can. There we go. I can make this a little bigger too. So in ObjectiveC, how many of you guys have experience with ObjectiveC? You've got a very small amount of people who have experience with ObjectiveC already. So basically the history of ObjectiveC is it comes from a company that Steve Jobs started called Next, based on a lot of concepts such as small tabs and other object-oriented languages. There's a really interesting history behind it, but the Objective-C that's used today comes from Next, so you'll actually see things like, you know, in Python, for example, if you just wanted to have a string, you would say like, my string, and you would just, boom, you have a string. But in Objective-C, it is a typed language, so you would actually define your string. So you would actually say ns string, you put a little star because it's referencing a dynamic amount of memory, it's a pointer. My Objective-C string, and for the compiler you actually put a little @ sign in front of it. It lets it know that this is a string. String. Boom. And you put a semicolon. Why did I pick Python? These two are my two favorite languages, Python, Objective-C. They both have different things to offer. Another interesting thing here about Objective-C basics is you would actually call this my Objective-C string. The naming in Objective-C is very verbose. I'll give you a great example of how verbose it gets. My personal favorite in Objective-C is if you're making an iOS app that has like a web view, you have an HTML page, you can pass JavaScript to that. Well, how do you pass JavaScript to that? So let's say you have like a web view, right, which is something provided by Apple's programming framework. We'll just assume that we have one. You can actually get a string from it, or here, we'll just pass it. So you say web view string by evaluating JavaScript from string. Now, that is a crazy sounding method, but if you did this, ns string title equals this, if you did this right here, one, you would be using Xcode, and Xcode gives you lightning fast completion, so you would not have to remember that entire thing. You would just start typing like string and it would start giving you auto completions for it very nicely. But the nice thing about Objective-C is a lot of times you don't have to reference the documentation because the functions are the methods are so verbosely named, you know exactly what's going to happen. This is going to give you a string by evaluating the JavaScript in a string. So what does that mean? Let's say you went to Apple's website in a web view and you ran this function. This function will actually take the string that we have there that says document title, and it will run it as JavaScript, take the response from JavaScript, and return it back to you as a string. So if you did this on a web view, you would actually get the page, the title of whatever page is loaded. So if you built a web browser in Objective-C, you would use this function every time the page changes so that you could put the title on the top of the screen, or maybe if you're going to email a page, you can get the title of the page. But the point is that it's a very interesting and unique language, and sometimes it's very difficult to wrap your head around it the first time, but once you do, it kind of makes a lot of sense. So I'll give you guys an example of a Python type way to do that, is you would probably say like title equals webview dot run JavaScript or something, right? And you would put in here document dot title, and that's what it would look like in Python. But here instead, of doing that, you actually say, instead of WebView dot, like run JavaScript or something, you say WebView run JavaScript, right? So it's weird. You encapsulate these methods as the idea here is called a message. So you're going to pass a message, which you encapsulate in these brackets, and you put the arguments here, like document dot title. So, is everyone with me so far? Anyone lost at all on these very weird Objective-C syntax things? Yes?
So what's the at sign for?
The at sign is telling the compiler that this is a string. It is a shortcut. And if you were writing iOS code 5 years ago, you had the very fine pleasure of making arrays where you would say like array with objects, and you would like just list objects, and then you would put nil at the end of it, and you're like, what am I programming in the 1970s? And Apple, in a very aptly way, came by and also just gave you at sign and then normal array syntax like you would expect. So the at sign in the compiler kind of is telling the compiler that it's going to be one of these special types. I'm not sure the exact technical term for that, but that's exactly what it's doing. Cool. So let's clear this stuff out. And we're going to get back onto the rails of this tutorial. And this tutorial is really interesting because it's going to let us preview in the web browser. So it actually runs the code on a remote server in a simulator and pipes that back to us. So one of the things, the first thing we're going to do is we're going to create the character. And so we're going to start off by creating the character. And what this, yes?
Wait, just how do you get to the page?
Oh, to this page? Make.sc, like SC, like USC, slash full Flappy. FULLFLAPPY. Yeah, so feel free at this point, if you guys want, you can follow along. It's not going to be the most amazing if you follow along. We can all just do it here really quickly. So what this does is we're taking character, which has already been defined in this class, and we're going to initialize a Flappy character, if you will, by calling on the character class create Flappy. That's how you would read that line of code. And then the next thing, which is very important, is what do we now do that we have this character? It's got memory. You know, who cares, right? We're just wasting memory with this character, and we're going to add it to our physics node. Well, what's a physics node? Well, in this case, in the game library we're using, the physics node just says, hey, everything that's going to be in here is going to have the option of having real physics enabled on it, having gravity calculated on it, collisions collected on it, that kind of stuff. Okay? Run this, and I feel already bad for our Flappy Bird friend here because once he loads, oh, yes.
Where does physics node like come from? Like, what
So-
package or anything is it from?
So in this case, that's a very great question. Where does physics node come from? Well, when you build interfaces in iOS, sometimes you use a tool called Interface Builder to actually sort of lay out where things are going to be on the screen. And in that tool, sometimes you actually like map objects that are in this design to the actual class that's going to control that. In this case, we're doing something very similar with the game library. So we have, you can't see it in this thing, but if you go to the full tutorial later and you download Xcode, which is free, you download Sprite Builder, which is free, you can actually open the files and you can actually see where physics node is defined. And there's a whole like C++ based physics library driving it too, and it's all open source, so it's pretty cool stuff if you're really into that. But anyways, our poor bird friend here, very, very, very sad. Our poor bird friend, he just fell down. So this is a little bit more of a rundown on Objective-C syntax, so we can run through it really quickly. This is when you make a function and you say what kind of variable that function is going to return. That's what the syntax looks like. So this here is void initialize, but let's say I wanted to make a method that says hello and whatever name I get. Well, you could start off by saying like ns string. This is going to return an ns string hello, and you could put ns string name, and that's actually going to say what it takes in. The minus at the beginning basically says that this is a method on the object. So I'm not sure how many of you guys here have done object-oriented programming yet, but if you have a class, you can have a class method on it, which in Objective-C is represented by having a plus sign. So you can just call that on the class. Great example of that in Objective-C is you can ask a class for its name. So you can figure out what kind of class it is. But the minus means that it's going to be a method that's callable on the object. And here's our first parameter, name. And we would implement this really easily by just saying like return ns string, string with format. Again, this is way easier when you're actually using Xcode. To have autocomplete, have everything fill in for you is very nice. But you would make a string format, very similar in some languages where you use, %f, stuff like that. So you say percent %at for a string, and you'd say hello, person's name, and close that string, and then boom, right? That would just return hello and the person's name. So this is a little bit more of just the syntax. Again, Objective-C syntax can be very, very confusing and intimidating at first, but if you just read a little bit about it or go through some tutorials, you'll get it, you'll understand it, and you'll see why it makes sense. Okay, perfect. So we're going to go ahead and delete this. Also, interesting thing really quickly I'll touch on about Objective-C. Yes?
Sorry, my screen is different from you, although it says start to fly, but it's like basic syntax. It's not method syntax.
Huh. I am not sure why we have a different one, but we'll just, so for the people who came in late, we're going to just run through this really quickly. Questions, of course, are appreciated. I want to make sure everyone's making sense of what I'm saying up here. I don't know. But at the end, I'm going to have 30 minutes free for all. You can come up here. You can ask me, why doesn't Google know the answer to this? You can ask me any programming language question, career questions, entrepreneurial questions. Cool. So last thing from this thing about syntax is you actually have, in a very interesting way, if you've programmed, how many people here have programmed regular C? Perfect. How many people have programmed JavaScript? Awesome. This line here looks very unsimilar to the rest of the things in this file. That's because part of Objective-C is that it's a superset of C, so at any time you want to, you could just do C-like things. So you could actually just, in here, you could say like int I equals 0, int I plus plus, and just do whatever kind of C things that you want to do, and it just works. Okay, so that's a little bit more of the getting used to the Objective-C syntax. Now, in the game library that we have, some of the ways that a game library might work is there's an update method that gets called at a frequency interval. So every time that your update gets called, you know a certain time has passed, and you can move or move the character or do things based on that. In this case here, we have this update method, and this again is defined by the framework. So we have a subclass of a scene that already has this update method, and there's already a timer and all sorts of crazy things that are going to call this for us, and we reliably know that we're going to get it. And when we get it, we're also going to know the amount of time that's lapsed since it's been called last. So all we're going to do in this method is we are going to say that the velocity of the character, which has an x and y component, is now going to be moving. Very simple. So let's see what that looks like. And again, you'll notice here that this is a C-type syntax. I thought the physics language, the physics framework that this is based on was written in C++, but it may be written in C. And that's why you just randomly in the middle here have this on the left side and this on the right side just being C. Okay, now let's take a look at our game. So you'll see here that the character is moving forward. It's very hard to tell, but you can see that the character is technically moving forward even though it's stuck on the ground. Again, very, very sad for our Flappy Bird friend. Okay, so there's a lot of boilerplate code here, but we're just going to run through it really quickly. And again, this is an example of kind of like an introductory tutorial. If you go to the URL, which I'll put up again at the end, you can have access to a full library of comprehensive tutorials that include everything from Flappy Bird to Game of Life and an art library for making your own games. So we're going to add an obstacle to the scene. We're going to, in our class definition, basically have a private variable here that's a float, right? It's a standard C-type float. And we're going to use that to keep track of the time since we last put an obstacle on the screen. We're going to set it right after we add an obstacle in the initialization. And in our update method, what we're going to do is we're going to say, this thing it copy pastes, we're going to say, hey, we're going to keep track of the time since we've had an obstacle. Once it's been 2 full seconds, we're going to add another obstacle. Every 2 seconds, we're going to have an obstacle. So that's what that code here is doing. Very, simple syntax, exactly what you would expect. If, parens, brackets. Again, this here is telling itself to add an obstacle. And this is just resetting the timer. And the waiting game. So now we're moving forward and we have obstacles. And you'll notice we actually collide with the obstacles and nothing happens too. So we have a lot of programming left to do, so we're going to pick up the pace a little bit. Let's close this out. And you'll see also the obstacles are being randomly generated. Okay, so the great thing about having a physics engine in game programming and having object-oriented programming is that something else is going to tell us whether or not 2 things collide, and what those two things are, and we have to do none of the hard work of figuring out if pixels are overlapping or any of those things that aren't fun when you're trying to get an app into the store in a language that you don't know for the first time. Now, we're just going to put that, we're just going to implement, we're going to implement that method here. It's going to return a Boolean, and it's CC for, it's a chipmunk physics is what it's called. But chipmunk physics collision begin, and it gives us the pair of objects. And in this case, it's saying if a character hits the level. Okay? And if that happens, we're going to send ourself, the class, the object, a method called game over so that we know the game is over. And we also need to keep score. So we're going to tell the score to be visible, which is implemented in another method that we don't have here in this class visible to us. And don't you love it when copy paste does not work? There we go. So in between the obstacle objects, there is a invisible goal. And every time we hit this invisible goal, the goal doesn't actually force any physics on the bird. The bird will just fly through it. It doesn't have any real physics collisions. But when they collide anyways, we're going to increase the score, and we're going to remove the invisible goal from the scene that we have, because if not, it's going to keep hitting it. So we want to make sure someone only gets 1 point. And this method's going to get called every single time they collide. So the first time they collide, while they're colliding, we go boom. You're done, goal. Get out of there. Oops. Oh, what? Thank God it saved where we left off. Okay. What's interesting from visually looking at the code, I have a feeling that we're missing the thing that makes the character flap, which is kind of important for us. And we are definitely missing the thing that makes the character flap. So that is great. Let's see if okay, well, there's a very good chance that we missed that. So we are going to go steal it. Now we'll take this back to the internet. Okay, well, anyways, I am very, very sorry for that, but I will find the code on GitHub. I don't have it on this computer for this exact thing, and we will make it so that when you click it, the bird goes, so you can see that the score works and that we die an appropriate death. But in the meantime, yes, I'm going to open up for questions.
This step 3.
Okay. Thank you for potentially saving me. Oh, there's a step here called moving to the right. This step says adding a jump. Perfect. Thank you very much. Okay. So on our scene, one of the things in the game framework is the ability to tell us that a touch began. In the UI programming for iOS with Apple's frameworks, there's also similar things. If you want to get nitty-gritty with touches began, how many fingers are they doing gestures, all kinds of crazy stuff. But we're just going to register here that we have a method called touch began. And what we're going to do here is we're going to add a physics impulse to the bird so that it jumps. One of the things that students definitely learned over the course of the summer program about this physics library and other physics libraries is that you don't just want to monkey with something by manually setting its velocity, because that doesn't give you realistic physics. What you do is you give things impulses, like it jumps. And when it jumps, it factors in the new impulse along with all the existing things happening on the physics body. So now we should be able to play Flappy Bird and make billions of dollars in the App Store. As soon as this is done loading. Oh, there we go. This is the worst because there's lag. But there you go. You see the score. Some of our more, let's say some of the students in the summer who were a little bit more, had more attention to detail, rightly noticed right away this being like one of the first things that we did like in week one, working on this, not in the simulator, but in real Xcode with really changing your thing, adding the bird, adding the pipes, like actually building this game instead of having it have done for you already, is that you shouldn't really count going through the pipe until the person's gone entirely through the pipe. But that is something that you can change when you open the file and you have your pipe object as a goal. If you want, you can actually move your goal so that it's after the pipes for that scoring concern. Okay, cool. So before we go back into more questions, I am going to leave this up on the screen. So again, for people who came in late, go to this URL, bookmark it, write it in your notes, share it around the hackathon. This gives you access, I believe, to the $100 program for free, which has a tremendous library of resources for you to consume at your leisure. And it also has access to royalty-free art that you can put into making your own game in the App Store. Okay, so we'll start off formally with any questions you guys have about Objective-C, and then after that we can go informally to any debugging, any questions, rampage of help you guys may need. So any questions about Make Games with Us, the Make School program, iOS, Objective-C, shipping things to the App Store? Yes, something new.
So there are methods here. What kind of libraries are used, for example, in this?
So this is using something called Cocos 2D. It's one of the most popular 2D game frameworks for the iPhone. It uses a tool called Sprite Builder for laying out visually in objects, interfaces, and sometimes you lay out objects and then you add them programmatically and remove them programmatically, but you still like lay them out, define all their properties in Sprite Builder, and that works really well for collaborating so that you have these design attributes that are outside of the code. The company that makes Sprite Builder also has technology for making games that work on iOS, work on Android. So using this game library, you can also ship games to Android. Yes?
Is Swift just like another language to develop iOS apps, or?
Yes. So, great question. Swift is much more like Python, Ruby, a lot of more modern languages. It's definitely, Apple's a very interesting company because they have very nicely polished marketing products, that kind of stuff. I'm personally a fan of a lot of those products. And at the same time, as a company, they have command line tools that you would never see as a normal user, right? So an example on the command line of something that's really powerful is there's a command line called open. And you can, if you're in a directory, in your terminal, you can type open dot, and you get that folder in the Finder. You can also, let's say you're in a Git directory, you can say open dot -a, and then like source tree, for example, and it will open that folder in that application without you having to actually tell where that application is as long as it's open, or the full path. So it's like weird, a lot of these things are very powerful, but also very like polished in marketing. So Swift is something that is definitely a powerful force up and coming in iOS. There is a Swift version of this tutorial that you can use. I personally have not done a lot of stuff with Swift yet, mostly because from my experience in the real world yet, it's not, like people aren't shipping in large companies projects that are fully Swift. And the main reason why is you really need to understand the framework and all of the different things you can access in iOS. And like any framework, one of the ways that you read that is by actually reading the header files, for example, of the library that you're interfacing with. So like if you're not conversive, we'll say, in Objective-C, then you're really going to have a hard time trying to implement all the frameworks and third-party libraries that you have access to on iOS. So you still really want to learn the Objective-C core, but definitely play with Swift, kick the tires. On the Make Games O's website, there's a free tutorial for doing Flappy Bird in Swift. So,
Would you say that like Objective-C is like a fundamental to learning Swift, I guess?
it's only because if you're going to make an iOS app or a Mac app natively, you want to learn Objective-C so that you can understand the tools, the frameworks, reading the header files of the classes you're going to interact with, the classes you're going to subclass. And Swift may just be a way for you to express what you're trying to do in less code. So, you may want to get really good at reading Objective-C code if you're going to do Swift. You don't necessarily need to get really, really good at writing Objective-C code. That being said, I imagine in the career market, in the next 2 years, if you have a job that involves Swift, you're probably also going to have a code base that's partially Objective-C. Because one of the things with Swift is, in an iOS app, in a Mac app, you can have both Objective-C and Swift, and the only difference is how the files are made. Yes?
So the files that you included in the tutorial, the various .h files, what did those look like, and the classes that are affiliated with?
That is a great question. So in those files, the header files actually, the best way to describe header files in Objective-C is that a header file is sort of a promise of what you're going to make and what other things can expect from what you're going to make. So a header file says like, hey, these are all the methods you know about me. These are all the methods you can call. These are all the messages you can pass to me. These are all the things that I take. Here are the variables that you can read publicly of my class. And it's interesting because all the Apple libraries have header files. And you can read, all the Apple frameworks have header files that you can actually read and understand. But instead of having the .m file, which is an implementation file, terrible like verbal joke by the people who designed that. The .m file, you don't necessarily need to have access to that. So in the Apple headers and frameworks and libraries that you work with, you just get the header file, and then there's like a binary blob that has all the compiled code that you can do it. So when you're writing your own classes and your own software, in the header file, you again say, here are all the things that you can do to this class. And it's basically the promise of all the things that you can do with that.
And then, like within that .m file, what was needed to create the like we came in, the boot was ODD, and the background was ODD, we didn't have to like draw the, I guess, does that make sense?
Yeah, so in this thing with Cocos 2D, there's a thing called Sprite Builder now. It's forked off of something called Cocos Builder. So there's a .ccb file. And that .ccb file has its own GUI tool that you can come in and you can start making different things, and then you can wire them up to the actual variables in your implementation file so that they actually work. And that's where a lot of that stuff came from. That says, like, here are where the pings are, right? Here's what the, here's the bird, right? What type of class is the bird? Well, it's a, character, or it is a bird, That kind of stuff, a lot of that wiring is done in that graphical tool. And there are both free online tutorials on the main Games of this website, and also on other websites you can find on the internet. There's also this, which you can sign up for, which has, for you guys at least, free resources for more of that stuff. And you can start messing around with those files in a very, like Coco, ObjectiveC way. Those files are actually XML. So even though you open them up in a GUI editor, they're still very compatible with Git and version control. Like if you just add an object in the file and you put it into version control in Git, you'll actually just see a couple lines of XML is what's changed. And then for performance, they actually turn those into binaries so that they're much faster when you're accessing them in memory. So, which is a very, ObjectiveC type of thing that they do. They have p-lists, which look like XML, but when you ship your app, they all get compiled to binary. So, cool. Yes.
So in this exercise, for example, we made implementations for lots of methods like touch began, physics, collision begin, stuff like that.
Mm-hmm.
Is there a specific place where these methods are called to generate the simulation, or?
Yes. So the easiest way to answer that question is when you actually take the repository from GitHub, you can just put a breakpoint in that method, and you'll see the stack, and you'll see how it got called. Now, for those particular things that you asked me, I can tell you off the top of my head that touch began actually comes from the 2D game library. And those come from Apple's UI frameworks and libraries that tell you whether or not you had a touch, if you so care to receive such events. The other ones that all started with CC. Yeah, so those are called touch began because that's very much how they're named in the app language. The other ones are namespaced. In ObjectiveC, most things, classes, are namespaced with a 2-letter. So that's why it's CC, or CC Physics. That's all the Chipmunk physics engine, which again, I think was written in C++. No, it's written in C. It's definitely written in C. And then it actually has ObjectiveC wrappers around it so that you get nice, clean ObjectiveC code, even though you're calling this C physics engine that operates really, really fast. So you actually, in your scene, you actually set up in the code that we don't see here on this easy demonstration, you actually tell the physics engine that I'm the delegate and I want to receive all the messages that are possible about the physics engine, and then that's how those methods get called. So it's a delegate design pattern. Cool. Anything else? Last call on general questions. Yes.
What's the process like of getting an app to the App Store?
I would say painful. I think, again, speaking very opinionated as just an individual person, sometimes you download an app on Android and you're like, this thing is terrible, how did this get here? I have shipped Android apps before where I needed to put out a new build and I didn't have a micro USB cable, so instead of building to my phone with a micro USB cable, I put it in the Google Play Store and then downloaded it. So, you know, garbage in, garbage out. That doesn't mean all things that I enter are terrible. There's plenty of applications that go through much more stringent review processes inside companies and organizations. But the Apple process is very stringent, and it makes it very hard for things that are garbagey to come out. That being said, on both Android and iOS, a lot of times you get cryptic, weird messages from build systems like, you're missing this file, or you're missing this attribute. Or on like Google, you still, I think, self-sign your certificates and all sorts of weird things. And on both platforms, like you have to go through and like read all of these steps, and there's always a missing step, and it's always very like difficult. So I would recommend that if you care about mobile development, you try that process earlier rather than later. We're currently hiring for an iOS person and an Android person at the startup I work at, which is vital.co. And we're specifically in our job requirements for those people, the person must have managed the release cycle. They must have been the person who like actually uploaded the app to the App Store every time, actually like updated the version, made sure it got in, dealt with it if it didn't get approved, that kind of stuff, because it's definitely part of the process. That being said, it's pretty good for the ecosystem that they do that both on Android and on iOS. Cool. Last call. Yes.
Typically, how long does that process take?
So, I've told clients when I was doing more freelance stuff for iOS that the first time you're putting an app in the store, expect 7 to 10 days. And when you're putting an update, expect 1 to 3 days. So, I've seen plenty of times, again, you have no clout, you don't have millions of users, you have no representative at Apple, and you just like submit an update, and within like 30 hours, it's in the store. They do have ways that you can put in there like, hey, the last one will delete all your game data, and it's terrible, and everyone's gonna cry who uses it and give me 1-star reviews, and they'll like expedite that process if that's the case. But they won't do it for like launch dates. If you're like, hey, we promised everyone November 1st is when we're gonna have our app in the store, you'll get a nice email back from Apple that's like, we don't care. So, you know, they do give you tools in that case to submit your app early, get it approved early, and defer release. So you can have your app waiting to be released on your command in the middle of October, and then click a button and boom, it's in the store, so that you're safe if you're running a business where that kind of launch date thing is important. Cool. Well, I hope you guys enjoyed the session, and I'll be available for some random questions. Feel free to bring me code that doesn't work, especially in languages that I don't know. That's the most fun, and I'll help you with it. Thank you guys very much.